Elimination problem solving. And this is actually one of the most difficult type questions in grade 10 problem solving. Even if you get to the end of the course, these questions tend to be very different. It has to do with percentages and two linear functions. So it's an acid solution here. What volume in milliliters of 60% hydrochloric acid must be added to 100 milliliters of 30% hydrochloric acid to make 36% hydrochloric acid? Okay, it sounds like in the question, but this is not what they're going for. It sounds like you have 100 milliliters of 60%, and then you're going to pour more in so that your milliliters be higher. But with the information they've given us, there really isn't enough here because we don't know what the final milliliters they want to have. So we're going to have to make an assumption. We're going to assume in this question, a wonderful beaker here, that we're going to have part, actually I should draw it permanently so it doesn't disappear here. Put the waves in. We're going to have part 60% solution, part 30% solution, and the total measurement is going to be 100 milliliters, okay? The question to me seems worded different, but this is the assumption we'll make so that we can solve it. So what does that mean? That means, have you guys done let statements where maybe let x equal the milliliters of 60% solution?
Yeah.
Okay. And then let y equal milliliters of the 30% solution. Okay. So with that being said, and it's important that we have defined it that way, there are two equations we're going to build. We know that this is going to represent x, this part on top, and this is going to represent y. And we know in terms of milliliters, it's going to be 100. So the very first equation, we'll call equation 1, is x plus y equals 100. Because x and y are representing milliliters to us. Okay. The second question where it becomes a little difficult to set up, or sorry, not the second question, but the second equation. The second equation, we attach the percentages to the milliliters. Okay. So what we do is we find 60% percentage converted to a decimal is 0.6. We're okay with that?
Yes.
Okay. So 0.6x plus 0.3y is equal to, and because we need 36, that's what's really important here, we need 0.36 times whatever the total milliliters was. Well, we know what the total milliliters was. It's 100. So we're actually going to multiply it by 100. So this question can actually go a little further here.
Yeah.
That's going to actually be equal to 36 in the end.
Yeah.
So I'm just going to rewrite it that way. 6x plus 0.3y is equal to 36. So we'll call this equation 2. So now we have equation 1 and equation 2. So here's where we can start to use our elimination. We're going to write them beside each other. Equation 1 is x plus y equals 100. And equation 2 is 0.6x plus 0.3y equals 36. Okay. In elimination, the whole point is to get your coefficients in front of one of the variables, doesn't matter which one, to be the same. And then we can add or subtract depending on what we've used. Which variable would you like to eliminate, the x's or the y's?
The x's.
Okay, so if we're going to eliminate the x's, that means the coefficients of the x's must be the same.
Yeah.
Okay, so because this one is 0.6, I'm going to multiply this entire equation. I put a line there to say the entire equation by 0.6. Okay, so what we're saying now is equation 1 times 0.6. That's the new equation we're building, and it will be 0.6x plus 0.6y is equal to 0.6 times 100 is going to be 60. Okay, you can use a calculator if you need to, but that's what that's going to equal in the end. And I've crammed myself for space here. And then equation 2 is still 0.6x plus 0.3y equals 36. Now, eliminating is essentially adding or subtracting the two equations. In this case, because the coefficients have similar, or sorry, I should say the exact same operation, they're both positive, we're going to subtract the two. If I had multiplied by -6, then I would have added the two equations. Okay, whatever is easier for you, you go about doing. So when we subtract 0.6, subtract 0.6, you end up with 0. 0x. Normally they just tell you not to write anything, but I'm just going to show you that part. Okay, 0.6y subtract 0.3y. Well, that's going to leave us with positive 0.3y. And 60 subtract 36 is going to leave us with 24. The 0 times x is 0. 0 plus this is 0, or the 0 is not important, blah, blah, blah. So we're left with 0.3y equals 24. Beautiful. Now we can actually isolate. We divide both sides by 0.3. Okay. And y would be equal to 80? I think that's 80. We might want to use a calculator for that one. Let me just check. 24 divide. Yeah, okay. So 80. Well, what did y stand for? Y stood for percentage, milliliters of 30%. So we need 80 milliliters of 30% hydrochloric acid. Okay? But we're not finished. We need to know x. Now, I could do the exact same thing, or because this equation 1 is so very simple, if I just plug in my value of 80 here, what is x going to be? 80 plus what is going to equal to 100? So we plug it in to find out. Okay, so I'm going to take equation 1. I'll do it below so we can write our answer here. Equation 1 was x plus y equals 100. Well, y, we already know from before, is equal to 80. So we're going to replace y with 80. So x plus 80 equals 100. And you might already know off the top of your head what the answer is going to be, but we'll do it. When we bring 80 to the other side, we have 100 minus 80. So x is equal to 20. So we need 20 milliliters of 60% hydrochloric acid. So we take 80 of 30 and 20 milliliters of 60 to create 100 milliliters of 36% hydrochloric acid. Okay. Tough question to kind of work out, and I know I jumped around the page there, but our final answer, I'll highlight it, was all done here. Okay.